In this problem we have to show that the product of the perpendicular distances from the origin to the pair of straight lines represented by here. Pair of straight line is given as ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. We have to show that the product of the perpendicular perpendicular distances from the origin is mod c by square root of a minus b whole square plus 4h square. So, first we will write this equation. We will take this equation is equal to capital S. So, in the solution, let S is equal to ax square. This is the second degree equation. Here we are taking ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. This is our given equation. Here we are taking first equation, let L1x plus M1y plus N1 is equal to 0. This is equation number 1. And second equation we are taking L2x plus M2y plus N2 is equal to 0. Now we have to take the product of these two equations. Means the given second degree equation is equal to the product of these two lines. L1x plus M1y plus N1 equal to 0. L2x plus M2y plus N2 is equal to 0. I will write on the next page. Here it is. We have the second degree equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to L1x plus M1y plus N1 into L2x plus M2y plus N2. Now we will find the product of these two lines. So we will keep left hand side as it is, which is this is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to L1 into L2, x into x becomes x square. So here we will write L1 L2 x square. Now this L1x is multiplied by M2. So here we will write L1 M2 xy plus L1x is multiplied by N. So this becomes L1 N2 x plus second term is M1y. M1y is multiplied by L2x. So here we will write M1 L2, this is x into y, xy plus M1 M2 y becomes y square, M1 M2 y square. Now M1y is multiplied by N2, so this becomes M1 N2 y plus the third term is N1, it is multiplied by L2x. So here we will write N1 L2x plus N1 M2y plus N1 N2. Now here we have coefficient of xy and this is also coefficient of xy. So we will take this xy common, it becomes L1 M2 plus L2 M1. In these two terms L1 N2 and L2 N1 we are taking x common. From here we will take y common. So our pair of straight line becomes, on the left hand side it is a x square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to, first term keep as it is, L1 L2 x square, L1 L2 x square plus here we are taking xy common, so coefficient of xy is L1 M2, this is L1 M2, here it is L2 M1, M1 L2 can also be written as L2 M1, L2 M1 xy plus here we have M1 M2 y square, M1 M2 y square plus, now take the coefficient of x, it is L1 N2, L1 N2 plus here it is L2 N1, L2 N1 x. Now we are taking y common, so where it is y? Here we have M1 N2, M1 N2 plus it is M2 N1, M2 N1, now y we have taken out plus last term is N1 N2. Now we will compare this term with the left hand side terms. Now coefficient of x square is a, here coefficient of x square is L1 L2. So we get a is equal to L1 L2. Coefficient of xy is 2h. On the right hand side, coefficient of xy is L1 M2 plus L2 M1. L1 M2 plus L2 M1. Now coefficient of y square is b. Here coefficient of y square is M1 M2. So this b is equal to M1 M2. Now we have to take the coefficient of x. It is equal to, this is 2g. So we will take 2g is equal to, coefficient of x is L1 N2 plus L2 N1. L1 N2 plus L2 N1. Similarly, coefficient of y is 2f. Here y, its coefficient is 2f. The coefficient of y is M1 N2 plus M2 N1. M1 N2 plus M2 N1, and the constant term C is equal to N1 N2. C is equal to N1 N2. Now in the question it is given as the product of the perpendicular distances. So we will take the perpendicular distance from the origin, the perpendicular distance from the origin. Origin is 0, 0. Here we are taking the origin 0, 0 to the line. First line is, here we have L1x plus M1y plus N1 is equal to 0 to the line 1, which is L1x plus M1y plus N1 is equal to 0. So in place of x1 y1 we will substitute this 0 0. So here product of the perpendicular distance means we are taking, this is, suppose this is P1, product is denoted by the letter P. So first product perpendicular distance we are taking, this is the perpendicular distance, P1 is equal to, here we have L, in place of x1 we are substituting 0, L1 into 0 plus this is M1 into y is 0, M1 into 0 plus here we have n1 divided by under root L1 square plus M1 square. So 0 into L1 becomes 0, 0 into M1 is also 0. Here we get the perpendicular distance P1 is equal to N1 by under root L1 square plus M1 square. Similarly, we will write the perpendicular distance. Distance from the origin is 0, 0 to the line. The second line is L2x plus M2y plus N2 is equal to 0. Here also in place of x and y we will substitute 0. The second perpendicular distance is denoted by P2. P2 is equal to N2, here what we have to write, L2 into this 0. L2 into 0 plus M2 into 0 plus N2 divided by under root L2 square plus M2 square. Now the first two terms become 0. Here also we get N2 by square root of L1 square plus M1 square. So P2 is equal to mod N2 by under root L2 square plus M2 square. Now product of the perpendicular distances. The first P1 is the first perpendicular distance, P2 is the second perpendicular distance. So here we will write product of the perpendicular distances. So it is P1 P2 is equal to, first answer was C1 mod N1 by square root of L1 square plus M1 square into second one mod N2 by square root of L2 square plus M2 square. Now in the numerator we have N1 N2, so we will write P1 P2 is equal to, this is N1 N2 by under root, in the denominator L1 square is multiplied by L2 square, so it becomes L1 square L2 square plus here we have L1 square and this is M2 square, so L1 square M2 square, this is 2 plus M1 square L2 square, M1 square L2 square plus M1 square M2 square, M1 square M2 square. So in the question we have here we have a minus b whole square plus 4h square. So we have to write the given terms in this form, a minus b whole square plus 4h square. So to get this value we will write taking plus 2 L1 L2 M1 M2 and minus 2 L1 L2 M1 M2 in the denominator. So here we will write taking plus 2 L1 L2 M1 M2 and minus 2 L1 L2 M1 M2 in the denominator. So here we get P1 P2 is equal to, in the numerator this is mod N1 N2, keep as it is N1 N2, Here in the denominator we are writing L1 square L2 square under root, this is L1 square L2 square plus last term is M1 square M2 square, M1 square M2 square. Now in between we will write this is minus 2 L1 L2 M1 M2, and the next term is M1 square L2 square. This here we will write this term in the bracket. Now we will open the bracket, again we will write it is M1 square L2 square plus next one is L1 square M2 square, L1 square M2 square. Now we have plus 2 L1 L2 M1 M2 plus 2 L1 L2 M1 M2. Now it is of the form a square plus b square minus 2ab, and this is a square plus b square plus 2ab. So we will write P1 P2 is equal to mod n1 n2 by whole divided by under root. A means we have L1 L2 plus b means here we will write minus because this is negative sign, L1 L2 minus M1 M2 whole square. Now it is of the form a minus b whole square plus here we have L1 M2 plus L2 M1, L1 M2 plus L2 M1 whole square. Now in place of this we will substitute the values. L1 L2 means it is A, M1 M2 means B. So here we will write P1 P2 product of the perpendiculars is equal to mod N1 N2. In the numerator we have N1 N2, and here in place of N1 N2 here N1 N2 is equal to C. So in the numerator we will write C by under root L1 L2 means this is A minus M1 M2 is B, A minus B whole square plus we have L1 M2 plus L2 M1. This is L1 M2 plus L2 M1 is equal to 2H. So here we will write 2H whole square, 2H whole square. So 2 2s are 4, H into H is H square. So our required answer becomes product of the perpendicular distances P1 P2 is equal to P1 P2 is equal to mod C1 by square root of A minus B whole square plus 4H square. This is the required answer.